Today, we will talk about the Earth atmosphere. What is atmosphere? The atmosphere of Earth is the layer of gases, commonly known as air, that surrounds the planet Earth and is retained by Earth gravity. Earth is the third planet from the Sun, and the only astronomical object known to harbor life. About 29% of Earth's surface is land consisting of continents and islands. The remaining 71% is covered with water, mostly by ocean but also by lakes, rivers, and other fresh water. The atmosphere is an important part of what makes Earth livable. It blocks some of the sun's dangerous rays from reaching the Earth. It traps heat, making Earth comfortable temperature, and the oxygen within our atmosphere is essential for life. Troposphere is the lowest of the atmospheric layer and begins at the surface of the Earth and extends are about 4 to 10 miles. The temperature decreases without increase in altitude. The altitude is the height of an object or point of relation to the ground level.
So, good day. My name is John Marie Marceliano, and I was assigned to discuss the continuation of the 5 layers of the atmosphere, which consists of troposphere, stratosphere, mesosphere, thermosphere, and the exosphere. But I will give more emphasis to stratosphere, mesosphere, thermosphere, and exosphere. So let us start with stratosphere. In the Earth's stratosphere, the temperature increases with altitude. On Earth, ozone causes the increase in temperature in the stratosphere. Ozone is concentrated around an altitude of 25 kilometers. The ozone molecules absorb dangerous kinds of sunlight, which hits the air around them. Next in line, we have the mesosphere. In the Earth's mesosphere, the air is relatively mixed together and the temperature decreases with altitude. The atmosphere reaches its coldest temperature of around negative 90 degrees Celsius in the mesosphere. This is also the layer in which a lot of meteors burn up while entering the Earth's atmosphere. The mesosphere is on the top of the stratosphere. The upper parts of the atmosphere, such as the mesosphere, can sometimes be seen by looking at the very edge of the planet. So, next, we have the thermosphere. The thermosphere is the fourth layer of the Earth's atmosphere and is located above the mesosphere. The air is really thin in the thermosphere. A small change in energy can cause a large change in temperature. That's why the temperature is very sensitive to solar activity. So when the sun is active, the thermosphere can heat up to 1500 degrees Celsius or higher. The Earth's thermosphere also includes the region of the atmosphere called the ionosphere. The ionosphere is a region of atmosphere that is filled with charged particles. The high temperature in thermosphere can cause molecular to ionize. This is why an ionosphere and thermosphere can overlap. So, last but definitely not least, the exosphere. Very high up, the Earth's atmosphere becomes very thin. The region where atoms and molecules escape into space is referred to as the exosphere. The exosphere is on the top of the thermosphere. So that's it. I hope that you learned from me and I have shared a little bit knowledge on my own about discussing the 5 layers of the atmosphere. Once again, my name is Jo Marie Marceliano.
Next topic is oxygen cycle. Oxygen cycle along with the carbon cycle and the nitrogen cycle plays an essential role in the existence of life on the earth. There are three main spheres for maintaining the oxygen level in balance. These are the atmosphere, lithosphere, and the biosphere. Oxygen involves the movements between the biotic, which is the living factor, and the abiotic, which is the non-living factor. The biochemical cycle explains the movement of oxygen gas within the atmosphere, the ecosystem, biosphere, and the lithosphere. The oxygen is found from lithosphere, which is the solid outer section along with the Earth's crust, and it is the largest reservoir of oxygen. There are three stages of oxygen cycle. These three stages are All green plants during the process of photosynthesis release oxygen back into the atmosphere as a byproduct. All aerobic organisms use free oxygen for respiration. Animals exhale carbon dioxide back into the atmosphere, which is again used by the plants during photosynthesis. Now, oxygen is balanced within the atmosphere. Now, we have four main processes that use atmospheric oxygen. These are the decomposition, breathing, rusting, and combustion. Let's move first from the decomposition. Decomposition, which is the breakdown once living organism uses oxygen and releases carbon dioxide. The dead animal or plants decay into the ground and the organic matter along with the carbon, oxygen, water, and other components are returned back into the soil and air. This process is carried out by the invertebrates including fungi, bacteria, and some insects which are collectively called as decomposers. Next is breathing. It is the physical process which all living organisms including plants, animals, and humans inhale oxygen from the outside environment into the cells of an organism and exhale carbon dioxide back into the atmosphere. The third is rusting. Rusting or oxidation involves oxygen in order to create rust in any material like iron, alloy, when they are exposed to moisture and oxygen for an extended period of time, and new compounds of oxides are formed by the combination of oxygen within the metal. The last is the combustion. Combustion or burning of object or any organic materials including fossil fuels, plastics, and wood, burned in the presence of oxygen and releases carbon dioxide into the atmosphere.
Nitrogen is the most important essential element for all living organisms. Nitrogen cycle is a process of repeating cycle which nitrogen moves through both living and non-living things. Nitrogen must change form in order to move through the different parts of the cycle. Stage 1. Nitrogen fixation. In stage 1, nitrogen moves from the atmosphere into the soil. Earth's atmosphere contains a huge amount of nitrogen gas. Fixation means converting an element into a usable form. Humans need nitrogen and plants, but they can't consume it in the atmosphere. That's why nitrogen fixation helps. They convert nitrogen into a consumable form. Stage 2. Mineralization. Nitrogen moves from organic material such as a manure or plants material to an organic form of nitrogen that plants can use. The plant's nutrients are used up and the plant dies and become decomposed. Mineralization acts when microbes act on organic materials such as animals and plants when they become decomposed, and it will begin to convert it to a form of nitrogen that can be used by plants. Mineralization is a conversion of an element from an immobilized form to an available form as a result of microbial decomposition.
The third stage is what we call nitrification. Nitrification also occurs in soils. During nitrification, the ammonia in the soils produced during mineralization and is converted into compounds called nitrites and nitrates. Nitrates can be used by plants and animals that consumes the plants. But some bacteria in the soil can turn ammonia into nitrites. And now, the fourth stage is what we called immobilization. During immobilization, sometimes it is described as the reverse of mineralization. These two processes together control the amount of nitrogen in soils, just like plants. Microorganisms living in the soil require nitrogen as the energy source. These soil microorganisms pull nitrogen from the soil when the residues of decomposing plants do not contain enough nitrogen. And now, the fifth and final stage is what we call the nitrification. During the nitrification, nitrogen returns to the air as nitrates are converted to atmospheric nitrogen. By bacteria through the process we call the nitrification. This result is an overall loss of nitrogen form from soils as the gaseous form of nitrogen moves into the atmosphere, back where we began our story.
Good day. Now we will discuss about the climate change. First, I will discuss to you the definition of climate change. Climate change, this occurs when changes in Earth's climate system result in new weather patterns that last for at least a few decades or maybe a millions of years. Also, climate change is any significant long-term change in the expected patterns of average weather of a region over a significant period of time. What causes the climate change? It causes because of the human activity. I will give you an example. When we use our cars, the engine have a CO2 that going up to the air, and also when we leave our TV and lights on that uses electricity, there's a lot of CO2. There's so much CO2 in the air that covering us like a big blanket. And because of a lot of CO2 can make the air too hot. And that's called the climate change also. Things that we can do to prevent climate change. First, we can ride a bicycle or walk instead of using our cars. Second, make sure to switch off our lights or TV. And third, we can use the recycled materials and many more. The climate change system consists of 5 interacting parts. First, atmosphere. Second, hydrosphere. Third, cryosphere. 4, biosphere. And 5, lithosphere. Remember, we need to change our way or climate change us. Thank you.
Global warming is a gradual increase in the overall temperature of the Earth's atmosphere, generally attributed to greenhouse effect caused by the increased level of carbon dioxide, chlorofluorocarbons, and other pollutants. Global warming occurs when the carbon dioxide and other air pollutants and greenhouse gases collect in the atmosphere and absorb sunlight and the solar radiation that have bounces off the Earth's surface. Normally, this radiation would escape into space, but these pollutants can last years to centuries in the atmosphere, trap the heat, and cause the planet to get hotter. That's what's known as the greenhouse effect. And over the past 50 years, the average global temperature has increased in the fastest rate recorded in history. And experts see that the trend is accelerating. But one of the 16 hottest years in NASA's 134-year record have occurred since 2000. So, what causes the global warming? It is caused by the greenhouse gases such as carbon dioxide, methane, and nitrous oxide, which is used by us humans. Most common greenhouse gases came from the combustion of fuel in our car, building, factories, and power plants. The top 10 causes of the global warming are power plants, transportation, farming, deforestation, fertilizers, oil drilling, natural gas drilling, permafrost, garbage, and volcanic eruptions.
Good day, everyone. Acid rain came from the mixing chemical reactions from air that made up of sulfur dioxide and nitrogen acid. Acid rain from the different air pollution made by the industrial burning such as power plant, factor, and other establishment that produce chemical substance that may harm to our environment and health. Other effect of acid rain is due to heavy rain may cause of damage to plant and animals because of the chemical came from the rain. The mixing chemical reaction hydraulic cycle has a many effects. It regulates the temperature of the surrounding. It changes reaction due to the different mixing chemical formed by the factories that reproduce smoke and other power plant that circulate over the surrounding. The fourth process of water cycle may apply such as evaporation that the heat or the temperature will rise that may form heavy to the sky. Condensation react to cause of heavy rain, downward and precipitation, uprise, heat, and other process down into different condition. It turn into vapor or stream such as river, lake, ocean, and goes into air. Thank you.
Ang susunod natin pag-aaralin ay tungkol sa mga smog. What is smog? Smog is a kind of air pollution. It is the mixture of smoke and fog in the air. So, smog daw is a uri ng air pollution na pinaghalo sa usok at fog sa hangin. Ito yung mga nakikita natin sa mga factories, yung binubuga na smog po ang tawag doon. And then, ano po sa tingin epekto sa ating health? Iwalang man natin ito. So yun nga, there are two types of smog, industrial and photochemical smog. Composition of industrial smog contains two primary components, which is sulfur dioxide and particulates. Particulate matter. Ito ay isang alang naman, pinaghalong solid and liquid particles in the air. Particulate pollutants, mga ano lang naman ito, which is mist, dust, fume, and smoke particles. Combination of sulfur dioxide and particulates can produce o makapagbuo na tinatawag ng acid rains, which can cause damage to crops and other plants. Nagbibigay ng mga sandiang pagkasira ng mga taniman at ibang buhay ng mga halaman. Industrial smog began with the Industrial Revolution and was most prevalent in the past 50 years with the heating of coal for heat and fuel. Okay, punta tayo sa susunod na slides. Narito pala ang mga ilang sakit o epekto natin kalusugan ng ating makuha. Una narito ang heart attack, bronchitis, pneumonia, tuberculosis. Grabe pala ito ang smog na ito. Kamatayan na ito agad ang dudulot sa iyo. Punta tayo sa susunod. May develop long-term or short-term health effects. Una rito, inflammation of lungs, permanent lung damage, increased risk of cancer. Okay. Children are more susceptible to disease. Grabe. Sa mga magulang dyan o mga kapatid natin, maging aware po tayo sa kanila para hindi po mangyari ito sa kanila. And nagdag ko lang pala guys, ano sa tingin nyo ang rason? Bakit nila ito ginagawa? Kung ganito lang naman ito ang kalabasan. How to control industrial smog? According to a study of Stanford University, smokestacks at factories and the other power plants have to reduce industrial smog by releasing pollutants higher in the atmosphere. Smokestacks, factories, and the other power plants, nakatulong daw ito upang mabawasan daw ang industriya ng usok by releasing pollutants higher in the atmosphere. And this solution can prevent the formation of smog. Though it is not a foolproof solution, it is the only reliable way to eliminate smog to reduce industrial smog. Ito daw isang solusyon na maaaring mapigilan ang pagbuo ng isang usok. Ito daw isang maasang paraan upang matanggal o mabawasan ang usok ng industriya.
Photochemical smog is a type of smog produced when ultraviolet light from the sun reacts with nitrogen oxides in the atmosphere. It is visible as a brown haze and is most prominent during the morning and afternoon, especially in densely populated and warm cities. Photochemical smog is a brownish-gray haze caused by the action of solar ultraviolet radiation on atmosphere polluted with hydrocarbons and oxides of nitrogen. It contains anthropogenic air pollutants, mainly ozone, nitric acid, and organic compounds, which are trapped near the ground by temperature inversion. These pollutants and also some other can affect human health and cause damage to plants. Photochemical smog often has an unpleasant odor due to some of its gaseous components. Photochemical smog formation. Photochemical smog forms from a complex process. However, the source of it is quite apparent. The largest contributor is automobiles, while coal-fired power plant and some other power plants also produce the necessary pollutants to facilitate its production. Due to its abundance in areas of warmer temperatures, photochemical smog is most common in the summer. Nitric oxide and nitrogen dioxide are emitted from combustions of fossil fuels, along with being naturally emitted from things such as volcanoes and forest fires. It is the immense concentration of these pollutants within cities that is of the most concern. However, as natural emission tends to spread out over larger areas. When exposed to ultraviolet radiation, NO2 goes through a complex series of reactions with hydrocarbons to produce the components of photochemical smog. A mixture of ozone, nitric acid, aldehydes, peroxyl nitrates, and other secondary pollutants. Compositions of photochemical smog. The following substances are identified in photochemical smog. 1. Nitrogen dioxide from vehicle exhaust is photolyzed by ultraviolet radiation from the sun and decomposes into nitrogen oxide. 2. Oxygen radicals then reacts with an atmospheric oxygen molecule to create ozone. 3. Under normal condition, O3 reacts with nitrogen dioxide to produce nitrogen dioxide and any oxygen molecule. 4. VOCs react with hydroxide in the atmosphere to create water and reactivate VOCs molecule. 5. The reactive VOC can then bind with an oxygen molecule to create an oxidized VOC. 6. The oxidized VOC can now bond with nitrogen oxide produced in the earlier set of equation to form nitrogen dioxide and reactive VOC molecule. Compositions of photochemical smog. The following substances are identified in photochemical smog. 1. Nitrogen dioxide from vehicle exhaust is photolyzed by ultraviolet radiation from the sun and decomposes into nitrogen oxide. 2. Oxygen radicals then reacts with an atmospheric oxygen molecule to create ozone. 3. Under normal condition, O3 reacts with nitrogen dioxide to produce nitrogen dioxide and any oxygen molecule. 4. VOCs react with hydroxide in the atmosphere to create water and reactivate VOCs molecule. 5. The reactive VOC can then bind with an oxygen molecule to create an oxidized VOC. 6. The oxidized VOC can now bond with nitrogen oxide produced in the earlier set of equation to form nitrogen dioxide and reactive VOC.
Good day everyone. We are gonna talk about air pollution. But first, let us define what air pollution is. Air pollution is when chemicals are added to the atmosphere by natural events or human activities in high enough concentration that is considered to be harmful. It is a mixture of solid particles and gases in the air. There are types and sources of air pollution. There are two main categories for this. The primary air pollutant, which is a harmful or which refers to the harmful substances that is emitted directly into the atmosphere. Next is the secondary air pollutant. This refers to the harmful substances formed in the atmosphere when a primary air pollutant reacts with substances normally found in the atmosphere or with other air pollutants. There are major air pollutants. These are substances, things or matters that contributes to air pollutions. These are things such as particulate matter like dust, lead, sulfuric acid, nitrogen oxides, sulfur oxides, carbon oxides, hydrocarbons, ozone, and air toxics. Nitrogen oxides are gases produced by the chemical interaction between atmospheric nitrogen and oxygen at high temperature. This causes greenhouse gases and causes difficulty in breathing. Ozone. There are two types of this, the bad and the good one. The bad one is the tropospheric ozone. This is a man-made pollutant in the lower atmosphere. It is considered as a secondary air pollutant. It is a component of a photochemical smog. Stratospheric ozone is a good thing. It is an essential component that screens out UV radiation in the upper atmosphere. A gas is a major part of air pollution in cities. When ozone forms air pollution, it forms smog.
Outdoor air pollution. Two main sources, transportation and industry. Car emissions, chemical from factories, dust, pollen, and mold spores may be suspended as particles. Ito po yung pie graph na
This is the pie graph. It shows the percentage of their contribution in air pollution. Transportation. Ito yung pinakamalaking contribution in air pollution, which is 57%. Example dito yung mga sinasakyan natin tulad ng jeep, yung mga usok nila, ganun. Next, fuel combustion. Ito naman yung pangalawang pinakamalaking contribution in air pollution. Dito nang gagaling yung mga pagsusunog ng mga plastic and kahit ano pa man. And next, industrial processes. Dito naman yung mga galing sa planta at pabrika. Miscellaneous. Dito naman yung mga pag-spray natin ng mga chemical. Carbon oxides. Gases, carbon monoxides, and carbon dioxides. Gases, carbon monoxides, it's a colorless and flammable gas. It also poisonous for us if we inhale it. Next, carbon dioxide. It's a common gas in the atmosphere and it's required plants like greenhouse gases. Greenhouse gases, any gas that has the property of absorbing infrared radiation emanated from Earth's surface and radiating it back to Earth's surface.
Good afternoon, everyone. Our next topic for today is all about the effect of air pollution, which can harm humans. So these are the following. First, low level exposure that can irritate eyes. For example, nitric oxide, nitrogen dioxide, and sulfur dioxide. These hazardous elements are known to affect the eyes by causing irritation, redness, and watering. Next, causes inflammation of the respiratory tract. Second, can develop into chronic respiratory diseases such as asthma, heart disease, lung cancer, and etc. Some air pollutants are poisonous. Inhaling them can increase the chance you'll have health problems. An example of this is the imitation of a factory, chemicals, industrial processes, and other natural sources. People with heart or lung disease, older adults, and children are the greater risk for air pollution. Is it obvious, right? And lastly, air pollution isn't just outside the air. Inside buildings can also be polluted and affect your health. This means that air pollution is everywhere. Despite effect of human health can cause death if we don't have or if we don't do an action. All the humans activities that we do in our environment will lead us to suffer. Air help us to breathe, but how air can save us if it is already polluted? Nature is our hope. We need to take care of the natural resources that we have and never abuse them. That's all for today. Thank you.